Hi guys, today we are with Jim Lewis, our in-house product expert, and today we're going to discuss industrial gear lubricants. Some of the things we're going to cover are the different type of gearboxes, typical applications, and what a customer should consider when purchasing a gear lubricant.
First, let's kind of talk about gear lubricants and gear applications and to kind of understand the lubes that are required for them. When we're talking about gearboxes or gears in general, what is a gearbox? What is a gear? Because sometimes they're commonly referred to transmissions as well, so it kind of gets a little confusing. But in the easiest terms, you're taking a power source and whether it be electric motor, your engine from your car, and then you're having to convert that to power force. And that's exactly what your gearbox does. It helps to convert that from a power source to a power force. Good example is your vehicle. You got your engine, and it's run away and it comes off your drive shaft coming out, and now you got to get it out to those wheels. That's what we use gearboxes to convert that energy, get them down to the wheels, and get them in motion. Another example would be gearbox in an industrial plant, on a conveyor line. It's an electric motor right there. Well, how do we get that power from that electric motor and get it to move that conveyor down the line or for other applications in there? We use gearboxes. So there's three main things that these gearboxes are doing, and one is converting power, and that's you take an electric motor that might be running at 3,000 RPMs, and they need to take that power to do all different types of things going down that production line. A simpler term would be your cordless drill that you use in your house. You know what I mean? Mm-hmm. It might have high speed for drilling, then it has low speed for torque. Right. And it's that same 12-volt battery as your power source, but now you have a gearbox that converts that energy to do two different things. If you have it in high speed for drilling, you can actually stop that chuck with your hand. Right. But now you put it for high force, it's same battery power, now you can't stop that chuck, Right. And that's what the gearbox is actually doing. So that's changing the force and changing it's that.
Like a higher speed, lower torque, or lower torque.
Well, the other one is, right, so then get hand in hand with that. It might also be an application where speed needs to be controlled. Right. So now you're taking that constant RPM or non-constant RPM, and you got to control that speed. In your car, you're pressing on that gas, your RPMs are going up, going down. You need to control that speed to the wheels. That's what our transmission does, right. Which is essentially a gearbox. That's what your differential does. It compounding effects. If you couldn't convert that 4,000 RPMs and control that 4,000 RPMs, it'd be very difficult to drive around a parking lot. You know what I mean? If that 4,000 RPMs are going right to 4,000 RPMs in those tires, you'd have a problem. Right. So no, it allows you to control that, and that's the second one. Okay. And then finally is directional. It just needs to, you have a power source coming out of a shaft this direction, but we need the power over here. So a gearbox will actually change the direction of power as well as the forces of power. So the differentials on your car, it's coming out that engine, the shaft going down, right. Goes into the differential. Now we got to send it out to the wheels this direction. So another application for a gearbox. So those are really the main uses of gearbox. So when you're looking at, say, a manufacturing plant, you got multitudes of these gearboxes throughout doing all these different types of operations. And that's kind of why we get into all these varying lubricants for all these different type of applications. Determine the viscosity. I mean, that's the key to all this. It's got to be thick enough basically to create a barrier between these two mating surfaces, and it's got to be thin enough to dissipate heat. It's got to dissipate air bubbles, you know what I mean? It's got to be thin enough to let the debris drop to the bottom, so it's a fine line between too thick and too thin, Too thick, you're creating too much internal friction. It's going to actually overheat the gearbox. Too thin, you're not getting the protection you need. So the first and foremost is determine the viscosity, and generally that's determined by the OEM. They're generally going to give your ISO viscosity grade or your AGMA grade, okay. Or even SAE type grade. Secondly would be your base oil quality. Can I get away with just a mineral-based gear oil? Or do I need a synthetic because it might be a high temperature type application? Or I might be trying to look for longer drain intervals, might be another reason I try to go for synthetic. And then additionally, your final thing you're looking at is additive makeup. Now I have my thickness, I have my base oil. Do I need anything additional added to it in order to get me the protection I need for that application? Or is there additives that might be detrimental to me if I'm actually using them in the application? You have extreme pressure additives. You have animal fat, which is tallow. That's a common additive used in these. And then tactifiers, simplest terms. Your chain on your bicycle, you might want to use tactifiers to keep that oil in place, on an open type gear application like that. But that's basically where we're talking about with these gear oils. And it's a varying group of products, and you really got to pay attention to, like we said, first and foremost, your thickness, then back to your base oil quality, and then on to your additive makeup.
That's great. Thank you, Jim, for that explanation on industrial gear lubricants and what one should consider when purchasing their industrial lubricant type. For more information on individual industrial gear oils or other videos like this, please visit petroleumservicecompany.com.